Hey guys, in this lecture we will consider equations that involve rational expressions. In this video we will see three different methods in solving rational equations. One of them is described in this slide, and for the other two methods I will discuss them briefly using the examples that we have prepared in this slide. So, in order to solve an equation involving rational expressions, one may multiply both sides of the equation by the least common denominator, or LCD, then solve the resulting equation. Now, keep in mind that the denominators appearing in the rational expressions must not be equal to 0. So, in this case, checking for the values that we will obtain after our computation is somewhat required, just to check whether we actually got the solutions for the rational equations that we are solving. So notice that we will also need our skills in finding the LCD of the rational equations. Meaning we have to find the LCM of the denominators that appear in our equation. So anyway, let us consider this example. We want to solve 2x over x squared minus 4 equals 4 over x minus 2 plus 3 over x plus 2. Now, we look at the denominators. We have this denominator, x squared minus 4, and then we have this denominator, x minus 2, and then this denominator, x plus 2. To get the LCD, we consider all the factored form of the denominators that we see. So we have x squared minus 4, which can be factored into x minus 2, x plus 2, and then the other denominator, x minus 2, and then the last denominator is x plus 2. So when finding the LCD, we consider all the factors that we see in all the denominators, and then take the highest power that factor has. So for instance, if we consider the factor x minus 2, the highest power of x minus 2 in this factored form is 1. Here we have also x minus 2, which is just of power 1. In here, we don't see x minus 2, so the power of x minus 2 is actually 0 for this expression. Therefore, in the LCD, we will only see x minus 2 power 1. Similarly, we now consider the next factor, x plus 2. And here, power of x plus 2 is 1. Here, power of x plus 2 is 0 because it does not appear there. Here, the power of x plus 2 is also 1. So the highest power of x plus 2 is also 1. And there are no other factors left to consider, which means that the LCD for this expression here, or this equation here, is x minus 2, x plus 2. But notice, x minus 2, x plus 2 is just x squared minus 4. In any case, we are going to multiply x squared minus 4 on both sides of the equation, meaning we will multiply x squared minus 4 on this side as well as on this side. And then next is to just multiply this over this expression here, and we will see that this x squared minus 4 will cancel this x squared minus 4. On the other hand, for this expression, we will distribute that over this group. And since x squared minus 4 is equal to x minus 2, x plus 2, and we have a denominator here, x minus 2, once we distribute this into this part, we will end up with 4 times x plus 2. Similarly, if we distribute this expression into this part, the x plus 2 will cancel the x plus 2 here, so that we will end up with 3 times x minus 2. So if we have it rewritten, we have the following. 2x equals 4 times x plus 2 plus 3 times x minus 2. So again, in here, x squared minus 4 is cancelled, so we are left with the 2x. In here, when we distribute it in the first addend, the x minus 2 will be cancelled, so you are left with the x plus 2, so 4 times x plus 2. And lastly, when this one is distributed here, the x plus 2 will be cancelled this time, and therefore you have 3 times x minus 2. So from here, we'll just simplify everything. We will have 2x. This one we distribute so that we will have 4x plus 8. This one will distribute also so that we will have 3x minus 6. And if we simplify this expression, we have 7x plus 2. And then we now solve the linear equation. So we end up with 2x equals 7x plus 2. We solve this equation. We will have negative 5x equals 2. Negative 5x equals 2. So solving for x, we have negative 2 over 5. And notice that the denominators are x squared minus 4, x minus 2, x plus 2. And the last sentence in the previous slide, we saw that the denominators cannot be 0. So we don't want this to be 0. We don't want this to be 0. We don't want this to be 0. But this 3 will imply that your x cannot be 2 or negative 2. And now, these are the only restrictions we have for our x. And all other x's will is allowed. They will be valid in the equation. And since our x equals negative 2 over 5, this will be the solution for this equation. You can also do the verification for the checking part. When you let your x equals negative 2 over 5, the left-hand side will be equal to the right-hand side. Take note that when you are doing the checking part, you have to do the checking part in the original equation. So if you substitute this negative 2 over 5 in this equation, you will see that the left-hand side is equal to the right-hand side. Okay? Now, for our next problem here, we want to solve x over x minus 2 plus 2 over x plus 1 equals 7x plus 1 over x squared minus x minus 2. Just like in the previous example, we look for LCD. We got the denominator x squared minus x minus 2. If you do the factoring, you will end up with x minus 2, x plus 1. And then for the other denominators, we got this x minus 2 and x plus 1 as well. And we clearly see that the LCD will just be x minus 2, x plus 1 as well. So for this one, we then multiply both sides of the equation by this LCD. So if we do that, noting that the LCD or the LCD x minus 2, x plus 1, this is equal to x squared minus x minus 2. So we are multiplying both sides by this expression. And then if we do the multiplication on this left-hand side, we will see that this one will cancel this one, so that the right-hand side, we will have 7x plus 1. On the other hand, if we distribute this over this sum, for the first one, we have a denominator x minus 2. So in this expression, the x minus 2 will be cancelled, and we will be left with x plus 1. So we will have x times x plus 1. And then plus, we got the 2. If we distribute this over this, the denominator has x plus 1. So in this expression, it is the x plus 1 that will be cancelled. So we will end up with 2 times x minus 2. So we have it in this expression. And then we just expand this multiplication and then simplify. So in here, we distribute this over this and this. Here, we distribute this over this and this. So we have x squared plus x plus 2x minus 4. The right-hand side, this is still 7x plus 1. Now, if we simplify this, we bring this to this side, bring this to this side as well, we will end up with the equation x squared minus 4x minus 5 equals 0. Now we are left with a quadratic equation. So we can do the quadratic formula. But in here, what I'm going to do is to use factoring. So you can factor this into x minus 5, x plus 1 equals 0. So coming from this expression, we will have x minus 5 equals 0. While coming from this expression, we have x plus 1 equals 0. Now, let us check the denominators. This one, or this one. So we don't want them to be equal to 0, meaning you got your x squared minus x minus 2 cannot be 0, x plus 1 cannot be 0, x minus 2 cannot be 0. In all of them, this only means that your x cannot be equal to 2 and negative 1. X cannot be 2 comes from here. X cannot be negative 1 comes from here. And take note that this expression here is just the product of these two expressions. Now, we see that x plus 1 cannot be 0, but this one here, we have this x plus 1 equals 0, so this part here cannot happen. Okay? So this one, this expression here cannot happen. Because if it happened, the denominator will be 0 for this expression here and this expression here, and we don't want that. So this one here cannot happen, but this one, for the other one, this implies that x equals 5. And since this is not one of the restrictions up here, then this is the solution. You can do the checking part if you let your x equals 5 in your original equation here. The equation will be satisfied. Right? So in these two examples, this one and the previous one, we used the LCD method. We needed to find the LCDs, and then we multiply both sides of the equation by their respective LCDs, and then we solve the resulting equation. Now, let us consider this example. And in this example, what I'm gonna do or what I'm gonna use is a different method. So in this method, basically, we will use the fact that if A over P equals C over P, meaning if there are two fractions that are equal and they have the same denominator, this denominator and denominator here, then we can just equate their numerators. Okay? So how are we going to use that one here? So basically, this one here on the left hand side, there's only one expression. That's your 2x over x minus 2. And then on the other side, there are two expressions. There's 1 and then there's 4 over x minus 2. So what we're gonna do is to combine for this right hand side, to combine them and make them a single fraction. So for the left hand side, we have 2x over x minus 2. For the right hand side, if we combine them into a single fraction, the denominator will be x minus 2. For the numerator, you will have 1 times x minus 2 and then plus 4. So in here, notice these are two fractions and they have the same denominator. This means that we only need to equate this numerator here with this numerator here. That is, you will have 2x equals x minus 2 plus 4. Now, if we solve for x, we will have, so this one, we bring it to this side, we will have 2x minus x equals, for the right hand side, we have minus 2 plus 4, this is equal to 2. Simplifying, we will have x equals 2. But now, let us check the denominators. Particularly, there's only a single denominator. Actually, there are two of them that we see, but they are the same. Anyway, we got x minus 2 in the denominator, and we don't want this to be equal to 0. But this is equivalent to saying that we don't want our x to be equal to 2. However, we got that here, x equals 2, but we don't want our x to be equal to 2. So this means there is no solution, or there are no solution. There are no solutions. Because, again, we found that x equals 2, but we don't want our x to be equal to 2. And there are no other candidates after solving this equation. So there will be no solutions. Okay? Now let us consider this next example. So in here we have 5 over 4x equals 1 over x plus 1 plus 3 over 2x. Now, what I'm gonna do here is the third method that I want to show. In this method, suppose we have two fractions that are equal and they don't have the same denominators. For example, if a over b equals c over d, then we can do cross multiplication. Then we have a d equals dc. So this is the method that we are going to use for this example. Of course, before we do that, we have to make sure that, you got one fraction equals another fraction. So for that, what we're gonna do is to bring this to the other side because the denominator, this one is 2x, the other one is 4x. We can easily change the denominator of this into the same denominator of this. The denominator of this is 4x, the denominator of this is 2x. So if we just multiply both the numerator and denominator of this fraction by 2, then the denominator will also be 4x. Then we can easily combine it with this expression. So if we do that, we will have 5 over 4x minus 3 over 2x equals 1 over x plus 1. So what I was saying earlier is that if I multiply both the numerator and denominator of this expression only, then we will have 5 over 4x minus 6 over 4x equals 1 over x plus 1. So this one, since they have the same denominator, we can combine them easily into negative 1 over 4x. The other one is just 1 over x plus 1. So on the left-hand side, we just have a single fraction. On the right-hand side, we also have a single fraction. We can now cross multiply. So doing that, we will have negative of x plus 1. This is equal to 4x. Or that we will have negative x minus 1 equals 4x. If we bring this to the other side, we will have negative 1 equals 4x plus x, which is equal to 5x. And finally, divided by 5 on both sides of the equation, we will have x equals negative 1 over 5. Now, what are our restrictions? So, looking at the denominators, we don't want x to be equal to 0. We also don't want x plus 1 to be 0. But this one here, it means we don't want x to be negative 1. And the value of x that we have obtained is x equals negative 1/5, which means this will be the solution for this equation. Okay? Let us look at our next example. So here we got 2t over t squared minus 1 equals 1 over t minus 1 plus 2 over t plus 1. So in here we can do LCD method, or we can also do the cycle method, but we need to combine this into, we need to write this sum into a single fraction, and you will see that if you add them, the denominator will be equal to this one. So here we will have 2t over t squared minus 1 equals, if we combine to a single fraction, we need t minus 1 here, t plus 1 here. So we are just doing the general way of adding or subtracting fractions. And then what will be the numerator? We'll get t plus 1 plus 2 times t minus 1. And now noting that your t squared minus 1, this is equal to t minus 1 times t plus 1. This means that the denominator here is the same as the denominator here. So we can just equate their numerators. This one equals this one. So we will have 2t equals t plus 1. And then we distribute these 2 here. We will have 2t minus 2. So if we solve this one, this will cancel with this one. And then this means that since they will cancel each other, that's equal to 0. Here on the right hand side, we will have t minus 1. T minus 1, you get here plus 1 minus 2. So that's minus 1. And you still have your t, that's your t minus 1. But then again, what do we have in the denominators? Basically, we don't want this to be equal to 0 or this to be equal to 0. So t minus 1 cannot be equal to 0. T plus 1 cannot also be equal to 0. But then we have this equation, t minus 1 equals 0, which means this cannot happen. This one here um, can't happen. Therefore, there's no solution. There are no solutions. Okay? Some more problems here. We got 7s over s squared minus s minus 6 plus 2 over s minus 3 equals 1 over s plus 2. So this time we can do LCD method. You can do LCD method, you can do the other methods as well, as long as you have the conditions. But for this particular problem, I will do the LCD method. Now, what's the LCD? We got the denominators s squared minus s minus 6, but this is factored into s minus 3, s plus 2. The other denominators are precisely these factors, s minus 3, s plus 2. So in here, the LCD is s minus 3, s plus 2. So we have here 7s divided by s squared minus s minus 6 plus 2 over s minus 3 equals 1 over s plus 2. We multiply by that LCD, s minus 3, s plus 2. So we also multiply this by s minus 3, s plus 2. If we distribute this over this and this one here, for the first one, this will completely cancel this part, which means we have 7s. On the other hand, if we distribute this over this part, the s minus 3 will cancel this s minus 3, which means we have plus 2 times s plus 2. On the right hand side, s plus 2 will cancel this s plus 2, so we will have s minus 3. So now we are just left to solve this equation. We have 7s plus 2s plus 4 equals s minus 3. Then we will have 9s minus s equals minus 3 minus 4. And then we will have 8s equals minus 7, or that s equals negative 7 over 8. And if you look at this denominators, we just don't want, if you look at this, we don't want this to be 0, we don't want this to be 0, but this would imply that your s cannot be 3, s cannot be negative 2, and the value that we have obtained is negative 7 over 8, which means this is the solution. This one here is the solution. Okay? Next example here. We have 3 over 3 plus z minus z over 3 minus z equals z squared plus 9 over z squared minus 9. So we can use the LCD method, or we can combine them, particularly this part here, into a single fraction. Then we see what we can do from there. If we combine these two into a single fraction, we will have, so in here we will have 3 plus z, 3 minus z, and then in the numerator you will have 3 times 3 minus z minus z times 3 plus z. The other side you will have z squared plus 9 divided by z squared minus 9. Now, for this denominator, if we do the multiplication, the denominator will be 9 minus z squared. In the numerator, you will have 9 minus 3z minus 3z minus z squared equals z squared plus 9 over z squared minus 9. So notice this denominator is almost the same as this denominator. Almost. More precisely, 1 is actually the negative of the other. Z squared minus 9, this is equal to the negative of 9 minus z squared. If we simplify the numerator on the left hand side, you will have 9 minus 6z minus z squared. Denominator, we can rewrite this denominator as negative of z squared minus 9. For the other side, it's still z squared plus 9 divided by z squared minus 9. And then we can bring this negative to the numerator. If we do that, we will have negative 9 plus 6z plus z squared. Denominator will just become z squared minus 9. The other side, you will have z squared plus 9 divided by z squared minus 9. So now you can see they have now the same denominators. So we can just equate their numerators. For this one, we'll now have, let me just write it again, minus 9 plus 6z plus z squared. This is equal to z squared plus 9. And in here, we can cancel out z squared. And then for this one, we can bring to the other side so that the equation will become 6z equals 9 plus 9 equals 18. And solving for z, 18 divided by 6, that will be equal to 3. Going back to the original equation, these are our denominators, but this imply that 3 plus z not equal to 0, 3 minus z not equal to 0, but these two imply that your z cannot be 3, z cannot be negative 3. And then we found that z equals 3 in here. So this cannot happen, can't be, so therefore there are no solutions. Okay? Now let us consider some word problems. So here we have find a number whose reciprocal, take note, whose reciprocal multiplied by 12 is 4 less than that number. Find a number whose reciprocal multiplied by 12 is 4 less than that number. So let x be the number. Then we get the reciprocal of x, that's 1 over x, multiplied by 12. So 12 over x, the reciprocal of that number. So reciprocal of x is 1 over 12, 1 over x. Then we'll multiply it by 12 so that we will have 12 over x. This is 4 less than that number. So this is our working equation. We can solve this by multiplying both sides by x. If we do that, we will have 12 equals x times x minus 4, or that 12 equals x squared minus 4x, 4x, or that we have 0 equals x squared minus 4x minus 12. So in here, we can factor out, or we can use quadratic formula, but this one we can easily factor into x minus 6 x plus 2. So from this one, we will get x equals 6. And from this one, we will get x equals negative 2. So if we do the checking, let me do the checking part here. If x equals 6, or when x equals 6, when x equals 6, and x equals 6. So here reciprocal equals 1 over 6. Multiply by 12, we will have 12 times 1 over 6. This is equal to 2. And then for the other side, 4 less than 6. So this is 6 minus 4. This is equal to 2. So we have the equality. Now, when x equals negative 2, reciprocal, this is negative 1 over 2, multiply by 12. This will be 12 times negative 1 over 2, which is equal to negative 6. And then 4 less than negative 2. So this will be negative 2 minus 4, which is equal to negative 6. And they are equal. So both are solutions. Both negative 2 and 6 are solutions. Finally, find 3 consecutive integers such that double of the reciprocal of the middle one is the sum of the other two numbers. Again, find 3 consecutive integers such that double of the reciprocal of the middle one is the sum of the other two numbers. So in here, we can let x be the middle integer. Then the three consecutive integers are x minus 1, x, and x plus 1. Right? Because we let x to be the middle integer, then the integer before that will be x minus 1, and then the integer after that is x plus 1. Now, what is the situation? Double the reciprocal of the middle one. So 2 times the reciprocal of the middle one, which is 1 over x. So I'll just write it as 2 over x. It said this is equal to what? Sum of the other two numbers. So this will be x minus 1 plus x plus 1. But then x minus 1 plus x plus 1, this is equal to 2x. Thus, solving for x, multiply both sides of the equation by x, we will have 2 equals 2x squared. Or that we will get if we divide everything by 2. And then let's do symmetry property. Let us just interchange their positions relative to the equal sign. We will have x squared equals 1. And this means that x equals 1 or negative 1. So in here, I will leave it to you to verify that both x equals 1 and x equals negative 1 satisfy the conditions about the problem, the conditions in the problem. Particularly, if x equals 1, so if we look at this, if x equals 1, what are the three integers? 1 is the middle part. The next integer is 2. The integer before that is 0. And when x equals negative 1, so negative 1 is the middle part. The next integer after negative 1 is 0. And the integer before negative 1 is negative 2. So you need to test these three numbers satisfy the condition here. Double of the reciprocal of the middle one is the sum of the two numbers. And at the same time, or similarly, you test that this triple here will satisfy that same condition. So what I'm saying is both of them are the answers, both solutions, both sets. So this one here and this one here. Take note, our goal is to find those three consecutive integers. So find three consecutive integers. Okay. So that's all for this lecture, and thank you for listening. Till next time.